In this lesson, we'll take a look at why do we need programs? What is a program and how to learn to program. So I'm going to talk about a lot of concepts and then I'll do some tutorial as well as we move along. So learning to program is becoming increasingly important in a variety of fields. So no matter whether you're in the financial industry, pharmaceutical industry, health industry, and so on, learning to program is very important. And in a sense where most of these software programs or these various enterprise level softwares, they need customization. So each organization is different. Every company has its own set of requirements. So most times they engage these developers or programmers to customize their environment or their software to their own needs. So as processes and workflows become automated, virtually every field of human endeavor will be reliant on software and the people who create it. And we see this especially with the influx of mobile devices, apps, cloud computing. We know on the back end of things, there's a lot of programming that is involved. So programming is important and is becoming a necessity as technology is exponentially growing. Computers follow instructions. So computers are simply machines that are built for one purpose only, and that is to do things for us. But the computer itself does not really know what to do. We need to tell the computer, and we need to speak their language to describe what needs to be done. For example, if I were to click somewhere on the screen here, that implies that the computer is going to execute my command. That is, click of a mouse button. And then the computer is going to wait for my next command. Otherwise, if I do not send a command to the computer, nothing's going to happen. So essentially, all computers do is just follow instructions by humans. And similarly, when software developers, they create programs using language such as Python, for instance, all we're doing is we're telling the computer step by step what needs to be done. And in order to tell the computer, obviously we need to know the language that the computer understands. And that's what Python is all about. Users versus programmers. What's the difference? Users essentially see computers as a set of tools. So if I'm a user, I'm going to use the computer, I'm going to click on certain buttons, use various tools, and I'm going to gain some output. For example, word processor or spreadsheet. So I'm using an Excel spreadsheet here and I'm going to calculate or add certain values on the spreadsheet. I'm going to issue some commands to the computer and I'm going to get my total. Similarly, if I'm using a word processor, I can bold text, highlight text, increase the font size, and so on. Programmers, on the other hand, learn the computer ways. In other words, the way a computer understands the actual language. So programmers have some tools that allow them to build new tools, and they also sometimes write tools for multiple users as well as for themselves to automate certain tasks. So a good example using Excel as a programmer would be create a macro or create a Visual Basic script, for instance, that is going to automate your addition, subtraction, or any task that you're doing in your Excel environment. Similarly, you can also create macros in word processing programs and a host of other enterprise-wide applications or other software programs. So users simply use the tools and programmers automate those tools or create or speak the computer language. What is a code? What is a software or a software program? What are all these terms? What do they mean? So it's simply a sequence of stored instructions. As I mentioned earlier, it's a little piece of our intelligence essentially that we give to others. We figure something out and then we encode it and then we give it to someone else to save them the time and energy of figuring it out. So we write programs and we tell the computer to do certain things automatically so that others don't have to do it. So essentially, it's just a piece of creative art, some innovation, particularly when we do a good job on user experience. And within your experience, you might have come across certain software that are really easy to use, easy to navigate, easy to understand. The tools are right there on the screen, and you can simply use those tools to accomplish your task or certain goals. And that's what we mean by user experience. So a good programmer essentially keeps that in mind from an end user perspective. Instead of making things difficult, a good programmer's job essentially is to make things easy for the user. Some example of what a code looks like, or what a program looks like. At this point, obviously, it's all foreign, but no problem. We'll take a look at once we get into subsequent lessons. You'll be able to, in fact, do all of these. So this is just an example of various lines that we use within the Python program and create functions and create the program or create a script and then run these to get an output. Okay, so all of these are entered into the Python software program essentially, or the idle or the Python shell. And I'll talk about in subsequent lessons what those are explained. But for right now, just to give you an idea of what the code looks like. Let's talk to Python. So for instance, if I were to open up my Python interface and add certain commands, for example, how does Python work those commands? Okay, as I mentioned earlier, the computer is going to wait for my instructions. So if I instruct the computer to do something, it's going to do it. If I'm not, it's just going to stay as it is. Okay, let me in fact demonstrate. So for example, here's a simple command called import sys. In other words, I like to find out the version of Python installed on my computer. So in order to do so, I need to open up the Python program and then input this command called import sys, and then finally print parentheses sys.version and close the parentheses. And this would give me the results that you see on this screen. Okay, let me in fact demonstrate. So I'm going to switch to the Python application here. So here's my Python shell, which is, again, I'll explain in subsequent lessons, but for right now, once you install Python, you open up the actual Python shell, and this is what you're going to see. And the cursor is blinking. In other words, Python is now waiting for me or for my command. So for instance, if I were to, as a first example, just type copyright, okay, and hit enter on my keyboard, I'll get the copyright results for Python. Similarly, I can type credits or a license for more information if need be. Let me demonstrate the example that we looked at on our earlier slide. So I need to see which version of Python is installed on my computer. So first I'm going to run the command called import sys, hit enter key, and next I'm going to print parentheses sys version, this is closed, and notice at this point it tells me that version 3.5.0 is installed and gives me other details as well as to the last upgrade since Python was last. It's an open source, so on September 13, 2015, at this time and this version, that's the version I have installed on my computer. So this is a good way to check whether on your own computer, once you install Python, it's a good way to check whether it's installed properly or not. Okay, so this is again just a flavor, just to show you the Python shell, where essentially we'll be spending most of the time in this course. So I'm going to switch back to my slide here. So I demonstrated both the import sys commands as well as the copyright and license and credits you can also take a look at. So talking to Python is really using the Python shell. Whatever you do in that shell, Python would execute the command. Some of the elements of Python. 3 broad categories here. First is the vocabulary and the words. Just like any language, if you were to learn French, for instance, obviously you need to learn certain vocabulary, and as you gain more experience, your vocabulary increases. So Python uses vocabulary words and also uses the variables, and certain words are reserved. So for instance, you cannot use a reserved word as a variable. Sentence structure is the second category. You need to have valid syntax patterns. Otherwise, Python is not going to understand what you want done. And third is your story structure, constructing a program for a purpose. And story structure is nothing like a flowchart, for example. So it's a series of steps that you want the program to execute. And the more efficient your story, the more productive your story, the better program it is. So elements of Python essentially entails three broad categories. You need to know vocabularies, words, sentence structures, and then eventually your story structure. Here are some examples of reserved words in Python. Once again, you cannot use these reserved words as variable names or identifiers. And some example reserved words are return, break, global, for, continue, while, import, and I just demonstrated this example import in our previous slide where we imported our current version and took a look at which version of Python is installed on this computer. Python sentences, for example, we need to define and let Python know what needs to be done. What do we need accomplished? For example, if x equals 2, which is an assignment statement, so I'm assigning the value to x. And then I can assign it with expression. In other words, I can say x equals x plus 2, which means it's simply 2 plus 2 is 4. So when I print x, it's going to print the result 4. Let me once again demonstrate this using Python. So let me switch back to the Python shell. Here I'm going to say x equals 2, enter, and then I'm going to say x equals x plus 2, and finally I'm going to say print x. I get the error because print is with a capital P. So instead of capital P, it needs to be print. And notice Python is good at this because it knows whether this print is the correct value or not. And you can see this by the differentiating color. Here I had the capital P, which was in black, obviously, so Python does not recognize this. But when I use the lowercase p, it recognized that this is a valid command. So I'm going to say print x one more time, and my answer is 4. Okay, so you need to be careful. Obviously, once again, computer will only understand what you tell the computer to do. If you don't speak the language, you will get errors, and that's the best way to learn. As we move along this course, you will see that how you can develop efficient programs and understand the vocabulary, the sentence structure, and then finally your story. Okay, so this is a good example of the sentence and assignments. So let's switch back to our slide. So once again, Python sentences is x equals 2, x plus 2, and then you print your statement. Great. So in this lesson, we took a look at why we need program, the difference between programmers and users, a little bit of Python shell that you took a look at, what a program looks like, and in fact, I demonstrated a small flavor of Python language as well, so that you could see that we need to understand the vocabulary and words, the sentence structure, and then finally your program or your logic or storyline as you start creating these programs. So with this, let's move to our next lesson.